Good morning, Year 5. Welcome to this week's science lesson, all about some famous scientists. Part of our curriculum in science always looks at different famous scientists, and there are many, many people who are famous for looking at Earth and space. So before we get started today, though, I've just got a little warm-up task for you. Get you to think a little bit about what you learned about last week when we did our freaky solar system model. And I wonder if you can just write down just a couple of thoughts on how does the Earth move in comparison to other planets and in comparison to the Sun. And then my other warm-up task is, what shape would you describe the Earth, the Sun and the Moon to be? Pause the video and have a quick go at that now for me. Okay, welcome back. I hope you've paused. I hope you had a good go at that warm-up task there. And maybe you might have said about the Earth moving slower, maybe than some planets such as Mercury or Venus, but moving much quicker than other planets such as Saturn or Uranus. You might also talk about how the Earth spins on its axis and how it spins at a similar speed to Mars, and spins much, much faster maybe than Venus, and maybe how it spins a lot slower than Jupiter. And then, when you were talking about what shape you describe the Earth, the Sun and the Moon to be, I'm hoping you can think back to your very first science lesson that you had in school with us back at the beginning of January, where we told you that the planets and the Sun and the Moon are all roughly spherical. Remember, they're not perfect spheres, and that's all about the way that gravity affects the planets, but they are roughly a spherical shape, so around about the shape of a ball. Okay, let's get to thinking then about our scientists now. Take a look at my diagram. And I wonder if you can spot something about this diagram that's actually just a little bit unusual. Something that's not quite like other diagrams that you see of our solar system. I'll give you a moment, just pause the video and have a careful look. Okay, I wonder if you spotted something. I wonder if you spotted where something was just a little bit strange. Let's just have another look at another diagram now. Here, there are two different diagrams. And now I wonder, what do you think's the same about them? What's different about them? Can you spot the diagram which is correct? Have a pause and have a really careful look about them. What's different? Okay, let's go back to our first one for a second. I wonder if you spotted here, you've got the orbits being marked out on this diagram, just like we've seen before. But what's unusual is Earth is here in the middle, and then the other planets are orbiting. Mercury here is orbiting alongside the Moon, and the Sun is here on an orbit around the Earth as well. These little yellow dots are supposed to represent the stars. You might also notice that not all of the planets are on here as well. And then if you look at these two diagrams together, you've got the differences. You've got Earth in the middle compared to the Sun being in the middle. You've got the Moon is here orbiting around the Earth. And then here you can see that the Moon's got its own orbit around the Earth, very, very separate from the orbit of the other planets. Both of the diagrams have got the stars around the edge, and do show some other planets orbiting. So, the difference between these two diagrams is one shows a geocentric theory, which means that when scientists believe that the Earth was in the centre of the universe and the Sun, the Moon and other planets all orbited around it, compared to a heliocentric theory, where it says that the Sun is in the centre of the universe and the planets orbit around the Sun. Let's find out a little bit more about those things. So, up until the early 1500s, people believed that the Earth was central to everything. They thought the Sun, the Moon and other planets all revolved around the Earth. I wonder why this seems like such a logical explanation. Have a little bit of a think about that for a moment. I guess it seems really logical because when you're here on Earth and you see everything else around you, you're not thinking about necessarily where things are in comparison. But when you were just looking and just stood on the Earth, you see the sun appearing to move over the day. You can see the moon, and sometimes if you're really lucky looking out into the night sky, you might see a planet there, very, very bright in the sky. So I guess it would seem logical that it looks like everything is moving around us. Ancient Greeks and Romans knew about other planets you could see without a telescope, like Mercury, Venus, Mars, Jupiter, and Saturn. They could also see the sun and moon from Earth. They just assumed everything must revolve around the Earth. Ptolemy was a particularly famous astronomer who had this belief from ancient Greece. So I want you to have a little watch of this video now. This video tells us all about a scientist called Copernicus. Have a little watch and see what you find out about his beliefs about the Earth.
What's up? I am Nicolaus Copernicus, the Polish astronomer, scientist, and priest. And I am the man who has put the sun at the center of the universe. So, I know my big theory is a little controversial, and most people think that the Earth is at the center of the universe. But hear me out before you decide to unsubscribe. Okay, so up until now, in 1513, we have learned and followed the theories of Aristotle and Ptolemy, two great Greek philosophers and scientists. So, their views of the solar system are that the Earth is at the center, and that the Sun and other planets orbit us. Are you still with me? Good. But what if it wasn't true? I know, shock, horror. I bet some of you have just fallen off your chairs. What if in fact the Sun is the center of the solar system and all the other planets, including Earth, circle the Sun in orbits? My celestial model is called the heliocentric planetary system. I know that's a mouthful. Heliocentric means centered around the Sun. That, my friends, is exactly what I think happens. So, in Italy, when I was in university studying, and now I am here in Poland, I have been putting into practice my scientific method. The first thing I did was ask myself the question, is the Earth really at the center of the solar system? And then I began to research the existing theories from Aristotle and Ptolemy. Based on this, I then created my own theory, or hypothesis, as it's often called. This hypothesis was placing the Sun at the center. Then I carried out my observations of the planets and solar system, looking at how they moved through the sky. I observed and documented my findings over months, even years. Then I finally concluded the way the Sun moves around in the day and the planets move around the sky at night, I realized my hypothesis was correct. And just before you think that's all I've got to share, I also think that the Earth spins on its own axis. Basically, while you are watching this vlog, the Earth is spinning. How cool is that? Don't you think it's totally crazy what is happening to our planet? Being a canon in the church and a man of the cloth, I'm not so sure my findings will go down very well. I have, however, been working on an equation to prove that my findings are correct. But I don't want to bore you with that right now. You have enough to get your heads around. Just before I go, remember, the planets are not orbiting around us. We are all moving together around the Sun, even when it is dark. It's amazing what we can find when using observations. What will you discover? I'll be posting again soon to update you on my progress. But in the meantime, don't forget to hit like. Bye-bye!
I hope you enjoyed finding out a little bit about his thoughts and his findings. And then let's hear a little bit about this person, Galileo. You might have heard that name before, even if you don't know who Galileo is. Well, his approach to science was unusual at the time. Scientists didn't generally carry out many experiments to test out their theories. So effectively, Galileo developed what we now know as the scientific method of experimentation. He actually tested things out and checked what he thought to be true, in a way that Copernicus didn't quite so much. As a result of observing Venus and how it changed in view from night to night, Galileo published his findings suggesting that the Sun was at the centre of the solar system, not the Earth. This idea got Galileo into big trouble with the authorities of the Catholic Church, and they accused him of heresy, which is having an opinion that went against the general beliefs held by the Church. Have a little watch now about this little clip all about Copernicus and Galileo and their discussions about the Earth.
Who is the greatest scientific investigator of all time? Our contestants span 500 years of groundbreaking scientific discovery, but only one of them can be the winner. On today's show, trying to convince you that he's the greatest is Nicolaus Copernicus.
Welcome, Copernicus. May I call you Nick?
Certainly.
Well, come on then. What makes you think you're the greatest scientific investigator? You were born in 1473. They didn't have science in 1473, did they?
Of course they did. Although the subject was certainly undeveloped in many areas, particularly astronomy. For a start, everyone thought that the Earth was fixed at the center of the universe and that the sun and stars moved around it.
Why was that then?
Because that's what everyday happenings seemed to show. The sun appeared to rise in the morning and move across the sky until it set in the evening. It took a wonderful mind to think that perhaps the opposite might be happening.
The wonderful mind being yours, I take it.
Correct. It takes a great scientific investigator to see what everybody else has seen, but to think what nobody else has thought.
Well, what did you do? Spend every night gazing into the sky?
Good heavens, no. I retired to my study and worked jolly hard on my sums. You see, having the sun and everything move around the Earth made the math so complicated. But if I tried the same sums with the Earth and planets moving around the sun, then everything became so much simpler.
You're not saying science isn't complicated, I hope. Well, this award isn't for people who've been investigating something simple.
What I'm saying is that the world seems to work in as simple a way as possible. But discovering that simplicity often requires a great scientist, such as me.
And so, of course, you then studied the skies and took detailed measurements like a great scientific investigator should.
No.
Shouted your new theory to the whole wide world, then?
No. Not until just before I died. I was a priest, you see. That was my day job. And the church taught that the Earth was at the center of everything. It could have got jolly tricky if I'd said what I thought.
Aha. So, you had to leave it to somebody else to come up with the proof, didn't you? And take on the church, didn't you?
Well,
Of course he did. He left all the tough stuff to me.
And it's time to meet our next contender for the greatest scientist that ever lived, Galileo Galilei.
Welcome, Galileo. Or can I call you Gally?
Copernicus? Ha! Oh, give him his due. He had a good idea, but I was the man who proved it was more than hot air. I began to observe the night sky, the planets, madame, Jupiter and Venus, and I took measurements, thousands and thousands of them. And when I had all the details, I sat down and I proved what Copernicus could not, that his theory was right. The Earth did move around the sun.
Somehow I don't think you kept quiet about it, though, Gally.
Oh, too right, I didn't. I wrote about it, I shouted about it, even though it got me into trouble. The church even had me locked up. But they found out I was right in the end, and that is why I deserve to be named the greatest scientific investigator of all time, because I explained how the whole universe worked.
What do you have to say to that, Nick?
I'm afraid I have to disagree. Without me, Galileo, you'd have nothing to work on. Big ideas. That's what scientists have to have. That's why I am called the father of astronomy.
Well, I call you something else if you're not careful. A big idea is no good at all unless you can prove whether it is right or wrong.
Making huge
A real
leaps of
astronomer
thought.
must make
Daring to think.
observations.
Thank you, Nick and Gally. Well, will Nicholas Copernicus be elected greatest scientific investigator of all time? Or will it be Galileo Galilei? The decision is yours.
So I wonder, how then did Copernicus and Galileo change people's ideas? Think about everything you've just learned from watching the videos and think about how they change people's understanding of actually where the Earth was in the solar system in comparison to the Sun and the other planets. Okay, so your task then is to complete a poster to show the differences between geocentric and heliocentric models of the solar system. So can you tell us what each model is and the differences between the two models? Can you talk to us about how Copernicus and then later Galileo changed people's ideas about the solar system? You can see in my orange box the things that you need to include. You need to show me that you know how Copernicus and Galileo changed people's ideas and how the planets move in the solar system. And you can challenge yourself to try and present your own argument and refute the geocentric ideas of the past. Okay, so I have made for you just a little template that you might like to use so that you can explain about each of the different types of model. So that then you have got some little prompts about what's right for geocentric and heliocentric and talking a little bit about what Copernicus and Galileo discovered. Watch back through the video to help you to find the answers to the different questions. You can also present this yourself on a plain piece of paper if you would like to. I hope you have enjoyed finding out about how the Earth has been seen over different times and how those different thoughts have changed over the years. Look forward to seeing your posters. Bye.